Okay, welcome back. We're now in section 3.7, and 3.7 is on the limiting reactant. You remember that a reactant is something usually you start with. Two or more molecules will react together, and that reaction will form a product. So if you have a limiting reactant, you're limiting one of the reactants. You don't have as much as you would need to make all of the product that the balanced equation suggests that you can make. So I need a balanced equation. If I'm going to find out which one is limiting, I'm first of all going to have a balanced equation, and then you're going to have to give me an amount of both of the reactants, and I'm going to see which of those two amounts will reduce the amount of product that I can make. That will be the limiting reactant. So here's a balanced equation. I've got 4 moles of ammonia, and 5 moles of oxygen gas reacting together to give you 4 moles of nitrogen oxide plus 6 moles of water. It's actually nitrogen monoxide, but it's nitrogen and oxygen. So here's the balanced equation. Remember, you're going to go through the balanced equation at the end when once we get moles of everything, then we have a relationship between each of these reactants and products based upon the numbers of moles that we start with. So in this problem, we've got 2.5 grams of ammonia and 2.85 grams of oxygen. Now, some of this is going to be leftover. If there's more oxygen and all of the ammonia is used up and there's leftover oxygen, then the ammonia will be the limiting reactant. It's the one that gets completely used. If there's excess ammonia and use all the oxygen in this case, then this will be the limiting. Whatever you use up all of will be the limiting reactant. Whatever you have excess of, that's not limiting. The other one probably is the limiting reactant. So before we can make sense of this, we have to first of all go into moles, find out how many moles of each of these there are, and then compare it to this 4-to-5 relationship in order to determine which one will get you less product. So let's start here with ammonia. I was given 2.5 grams, and in 1 of ammonia, NH3, in 1 mole of ammonia, I'm going to have how many grams of ammonia? So I need to go to ammonia and find out what the molecular mass is, and I've got a 14 here. Nitrogen is 14. Hydrogen is 1 each, and there's 3. So 14, 15, 16, 17. There are 17 grams of ammonia in 1 mole of ammonia. So if I have 2.5 grams worth, 2.5 divided by 17 gives you 0.14 moles. Okay, 0.14 moles. Let's pick one of the two products and see how much you can make with 0.14 moles of ammonia. So let's just let's do this one since it's a 1-to-1 relationship. That's easy. I have 4 to 4, so that's a 1-to-1 relationship. That means if I have 0.14, I can make 0.14. Okay, so that's one thing, and now we'll compare that one with the oxygen, see which one will make less. Right now, if I'm using all of my ammonia, I can make 0.14 moles of this. Let's see what would happen with the oxygen. When I have 2.85 grams of oxygen, this is O2, oxygen molecule. Remember that from the periodic table it's 16, but there's 2 of them here. So 16 and 16 is 32. That's 32 grams of oxygen molecule in 1 mole of oxygen molecule. So I'm going to take 2.85, divide it by 32, and I have 0.089 moles of oxygen. Okay. Now this is not one-to-one, so we're going to have to actually do the cross multiplication. Let's start with oxygen. Let's go to this one again because we know what the other one amount was made. So let's say it's a 5-to-4 relationship. So 5 moles of oxygen to 4 moles of NO equals 0.089 moles of oxygen over X moles of the NO. So let's find out how much we can make. This is going to be 5X equals 4 times 0.89 or 0.089. So 0.089 times 4. Now I'm going to divide by 5 on both sides. Divided by 5. X is going to be equal to 0.0712 moles. So let's remember what we did. First of all, we looked at 2.5 grams of ammonia, and since it was a one-to-one relationship, we know that if that 2.5 grams is 0.14 moles of ammonia, then I can make 0.14 moles of the NO compound here. If I have 2.85 grams of oxygen, that's 0.089 moles, and with a 5-to-4 relationship, that gives you 0.07 moles of this. So 0.14 is much bigger. Okay, that means that this I would make less. So the oxygen is your limiting reactant. The oxygen is the limiting reactant. Whatever is going to be completely used up. Okay, completely used up. So, for instance, if I used 0.114 or 0.14, how much oxygen would be required to make 0.14? That's another way of looking at it. So, let's look at it this way. If this is 4 to 5, 4 moles of ammonia over 5 moles of O2, and I have 0.14 moles of ammonia, how many moles of oxygen would be required to make all of that 0.14? Okay, so let's look at it. This is going to be 4X equals 5 times 0.14 and X is going to be 0.175. If I'm going to use all of my methane, all of it up, all 0.14 moles up, in order to make 0.14 moles of this, I have 0.175 moles required. But I don't have 0.175. I only have 0.089 moles. That means that the oxygen is my limiting reactant. It's my smaller amount of moles in order to get a product made. The second question in this problem is how many grams of this form? Okay, well, I know that with this, let's see, you can only make as much as the smallest amount will make. You can't make the full 0.14 because I don't have enough oxygen. So I need to go from how much is 0.089 moles make? Well, so 5 to 4 is what we just did. 5 to 4 is 0.09 to X, and we see that that is 0.0712, okay, of nitrogen oxide. So how many grams is that? So you're going to have to start with what you have, 0.0712 moles. And in 1 mole, what is that going to be? This is 14 plus 16. So there's 1 and 1. So 14 plus 16 is 30 grams per mole times the number of moles that we found times 0.0712, and I get 2.14 grams. Okay, 2.14 grams. This is how much can be made with this smaller amount, okay? Because we don't have the full 0.14 moles. We only have this reduced amount, 0.07 moles. That's all that we could make. 0.07 moles through the periodic table gives you 2.4 grams. So that's your second question. And then the last question is, how much of the excess reactant remains after it is used up? Okay. Well, how much did we use? Okay. In order to make 0.0712 moles, how much of this did we use? Okay. So let's go backwards. We'll say that this is 4 to 4. 4 to 4, that's a 1-to-1 relationship. We only used this much. Okay? We only used 0.0712 moles. How much did we have? We had a full 14 moles. So if this one was 0.0712, that means it required 0.0712 to make. So this is how much we had 14.14 moles, and we're going to only use 0.0712 moles. How many moles of that is left? So 0.14 minus 0.0712. That's going to give you 0.0688 moles left over. And this is asking for how much. It just says how much. You could say 0.066 moles are left over. Okay, left over. Or you could put this into grams. Put into grams 0.0688 moles. And remember, there were in 1 mole, there's 17 grams. So times 17. So that's going to leave you 1.17 grams left over. Okay, so it's either 0.0688 left over or 1.17 grams left over. I may put another video explaining this online. Hope this helps you. See you in class.